Hey there, 13.3 is the last of your video lessons for this week, and here are the goals that go along with it. We are going to write numbers as powers, simplify powers that have an exponent of 0, and lastly, simplify powers that have negative exponent. Your group should be able to answer numbers 1 and 2 together on your own. Those are simple problems. All it wants you to do is simplify each fraction. 4 over 4 we know is just 1. Same thing for B and C. Go ahead and do those. Number 2, what is the quotient of any number divided by itself? So if you take 4 divided by 4, what are you going to get? If you take 100 divided by 100, what are you going to get? So you and your group can do that. If you need to pause, go ahead and pause. If you are ready to move on, you can just follow along with me. Number 3 wants you to write each numerator and denominator from this problem here as a power and do not simplify. So what power can we change 4 into being? Well, we can change 4 into being 2 to the power of 2 over 2 to the power of 2. Number 9, or 9 over 9, letter B, can be 3 to the power of 2 and 3 to the power of 2. I want you to try letter C on your own. Press pause, and when you get the answer, go ahead and press play. All right, hopefully you were able to find that 25 written as a power is 5 to the power of 2. Number 4 says simplify each fraction from question 3 using the quotient rule of powers. We learned that in 13.2. Again, when you have a quotient or you're dividing your bases, think about what you do with your exponents. Remember that we are supposed to be subtracting our exponents. It wants you to leave your answers as powers. So I'll do number or letters A with you, and then you can try B and C on your own. So if I take 2 minus 2 because I'm subtracting my exponents, I get an answer of 2 to the power of 0. So you try B and C. You can go ahead and fill those in. I'm assuming that you're going to get those pretty easily. You should be getting 3 to the power of 0 and also 5 to the power of 0. Number 5 says, although each power in question 4 has a different base, what is the value of each of these exponents going to be? If you have 2 to the power of 0, your answer then should be 0. And same thing for B and C. Write a rule that you can use when raising any base to the power of 0. Well, any time you raise a base to a power of 0, so again we have these examples of 2, 3, and 5, it is going to be equal to the number 1. So here we can go back and say that 2 raised to the 0 power is 1, 3 raised to the 0 power is 1, and same thing with 5. Here we see our little friend in his shark shirt again. He's telling you that this case does not work to get an answer of 1. 0 raised to the 0 power does not equal 1. He's saying because anytime we have a number divided by a number, we get 1. Well, you can't take 0 and divide it by 0 and get 1. It doesn't make sense. So this will not work. All right, in problem 2, we're going to start dealing with negative exponents. So number 1 gets us a little prepared for it. We're talking about how to get positive exponents. Each row you go down, they're going to want you to multiply by 10. So 1 times 10, we know that that is 10 to the first power. If we move down and we say 10 times 10, we know that that is 10 to the second power. And now if we move down and multiply this whole thing by 10 again, we have 10 times 10, and now times the last 10, we know that that becomes 10 to the third power. Describe what happens to the exponent as the number becomes greater. Well, the exponent increases just like the numbers being increased here. On number 2, we're going to start talking about negative exponents. So basically what's going to happen here is each time we're going to divide by 10 more. So 10 more than 10 would be 100, and 10 more than 100 would be 1,000. So if we write these in exponent form or with bases and exponents. 1 is just 10 to the 0 power, and 100 is 10 to the second power. Same thing here, 1 is 10 to the 0 power, and 1000 is 10 to the third power. When you're doing quotients or division, we subtract the exponent. So if I take 0 minus 2, so 10 to the 0 minus 2, I'm going to end up with 10 to the negative set 2 as my exponent. Here I'm going to take 10 to the 0 minus 3. 0 minus 3 is negative 3, so negative 3 is my exponent. So again, they want you to describe what's happening to the exponents as our numbers get smaller. Well, same thing here. Our numbers are also going to get smaller, or our exponents, I should say. So go ahead and write an answer in there for letter B, and then you can flip over to the next page and we'll do some more practice. In number 3, they're asking us to rewrite each sequence using, or each sequence of numbers using the definition of powers. So I'm going to look at all these numbers. And first I'm going to figure out what your base I'm going to use. And I noticed that each of these have 2 in them, so I'm going to use the base of 2. Since I have a fraction, I should realize back from what I did in question number 2 that I'm going to have a negative exponent. And I know that 2 to the negative 3 will give me an 8 on the bottom, or 2 to the third power would be 8. And again, since it's in fraction form, I know that my exponent is going to be negative. Well, think about what's going to give me, what exponent will get me to 4. 2 to the second power gets me to 4. And again, because this is in fraction form, I know that it's a really small number. My exponent should be negative. Same thing here. 2 to the first power gives me 2, but since it's a very small number, I need a negative exponent. 2 to the power of 0 gets me 1. Anything to the power of 0 would also get me to 1. Here my exponents are going to start to get bigger because my numbers are getting bigger. So 2 to the power of 1 gives me 2. 2 to the power of 2 gives me 4. And lastly, 2 to the power of 3 gives me 8. I want you to go ahead and try letter B with your group. Think about what base you're going to use. I'll give you a hint that it is not a base of 2 anymore. Think about what all of these numbers have in common. And go ahead and do kind of the same pattern here that I worked through. Really small numbers will have negative exponents, and bigger numbers will have positive exponents. Once you get done with B, you can go ahead and answer number C, or letter C, and describe what's happening with those exponents. Here are my answers to B and C. Again, I followed the same pattern. Small numbers have negative exponents, bigger numbers have positive exponents. My description for the exponents for letter C was, as the number gets bigger, so does the exponent. You and your group should be able to solve A, B, C on number 4. They want you to simplify the expression using the quotient rule. Remember, the quotient rule means if you're dividing your bases, you're going to subtract your exponents. And you'll notice that 0's on the top, so 0 minus anything is most likely going to give you a negative number. So 0 minus 3 will give you 10 to the negative third, and so on and so forth. You can follow those patterns and figure those ones out. I am going to skip the table on number 5. I think it's just kind of going to be confusing for you. So when you're done with number 4, you can go ahead and look at number 6 on the next page, 707, and we will work through that together. All right, in number 6, they're kind of working you backwards now. They're going to give you a base with a negative exponent, and they want you to get rid of the negative exponent because usually you won't see them written as negatives. In order to get rid of a negative exponent, we have to put this number under 1. As soon as you do that, your negative will go away. So go ahead and practice writing these without the negative exponent. Again, anytime you see the negative exponent, it means that it's going to be a very small number. And when you take 1 over a number, you turn it into a fraction or a decimal, that means it's going to be small. So here are my answers. Again, we know that we could simplify these a little bit more and just take 8 to the 4th power or 5 to the 6th power to simplify those one more step. All right, I'm going to move on to number 7 now. Number 7 wants you to complete the table. They say go ahead and use your calculator. I'm totally fine with that if you want to get your calculators out. They say your answer must be a whole number or a fraction. Do not write your answer as a decimal. I want you and your partners to go through and use your calculators to figure out the table. When you have that done, press play and I will get you the answers. All right, here are the answers to my table. Again, anytime you have a negative exponent, you want to move it to the opposite side. So I put now 3 to the second power over 1 just gives me 3 to the second power. So if you have negative exponents, in order to get rid of them, you need to move them from the top to the bottom or from the bottom to the top. And doing that will get rid of the negative sign. So my answer to the first one was 9. And if you look at the second column, again, that 4 to the negative 2 needs to be moved up to the top so that you get rid of the negative exponent. 4 to the second power over 1 is just 4 to the second power, and I solved that to get 16. As you get down further in the table, you'll notice that the negative exponents are up top. They need to be moved down to the bottom, so it will become 1 over 2 to the second power, and that's when you start to see the smaller numbers. So go ahead and check your answer with your table. Check the table, or check your table answers with your group. I shouldn't use table for both. And then when you have that done and figured out, you can go ahead and move on to question number 8 and 9. All right, if you finish your table, we're going to move on to numbers 8 and 9. It says, describe how to rewrite any expression that has a 1 in the denominator and a power with a negative exponent in the numerator. So what they're saying here is maybe 2 to the negative 2 is in the numerator, and it says 1 is your denominator. Well, I wrote, I must write a fraction that is equal to 1 divided by the power with its opposite exponent in the denominator. So instead, like we talked about before, you are going to move this down to the bottom, and it becomes 1 over 2 to the positive second power. Number 9 is kind of asking the opposite. How do I write an expression that has a 1 in the numerator and a power with a negative exponent in the denominator? So this time the negative exponent is on the bottom. I wrote the answer of I must write an expression that is equal to the power with its opposite exponent. So this one will become, like we said, move it to the top. It will become 2 to the positive second power. And again, technically that 1 is still there, but we don't need to write that part. On problem 3, I'm going to let you and your group work through on your own. It says the symbol for is equal to is obviously the equal sign, and the symbol for is not equal to is the equal sign with the little slash through it. And I got a lot of questions about that on the map test. I'm not sure if we've seen that before, but this sign means is not equal to. Write the appropriate symbol to compare the two expressions in this little box here. So basically they're asking, is 2 to the third power equal to 2 to the negative third power? So you go through with your group and answer numbers 1 through 4, and then when you're ready, press play, and I'll give you the answers. All right, here are your answers. In number 1, they are not equal to each other because a positive exponent is going to be a bigger number than a negative exponent. Number 2, they are equal to each other because this is what was really going on there. You can have it over 1, and what you would do is move this negative exponent down to the bottom, and it would become positive. So that's kind of how we flip-flopped between those two. Same thing here, the negative exponent was on the bottom, so we moved it to the top. They are the same, or they are equal. And this one, in this case, no, they're not, because the exponent on top is still negative in this situation. All right, if we move on to page 709, problem 4's got a little explanation here for us. It says the expression k to the 5th power times k to the negative 7th power can be simplified using the product rule of powers or the quotient rule of powers. So there's two ways you can go about simplifying it. Something really important that I want you to highlight, star, underline, whatever you need to do to remember, it says an expression is not considered simplified if it contains a negative exponent. So those negative exponents have to be put away or have to be taken care of in order for a problem to be considered simplified. So here's the two ways you can go about doing that. The first one is using the product rule of powers. We know that if you are multiplying the same base, you can add the exponents. And we know that 5 plus negative 7 gives us a negative 2. And we were told in this lesson 13.3, it's new to us, that if you have a negative exponent, you can move it to the opposite side of your fraction bar. So technically, this negative 2 was on the top. We would move it from the top down to the bottom, and it becomes positive, so we have k squared, and now we can put it under 1. The other way to do it is to set it up into a quotient problem right away. The negative can be moved to the bottom, so they put this k to the negative 7 down on the bottom so that it became positive. And then when you are dividing bases, you know that you can subtract them. 5 minus 7 becomes negative 2. And again, because that exponent is negative, it's not yet considered simplified. And you can move it to the opposite side of the fraction bar. That means it has to go down to the bottom, the negative sign will go away, and then it can be put under 1. Take a second to discuss this with your group. Walk yourself back through these steps so to make sure that everyone understands them. And then the rest of this page is a bunch of practice, so I'll go over a few problems with you, and then I'll let you work on your own for a little bit. So hopefully you and your group took some time to discuss those. These next 10 problems are going to work through the 3 rules that we've been discussing in section 13.2, and then a few of our new rules from 13.3. So I'll work you through the first couple of them, and then I'll let you guys work on your own, and you can come back to check your answers. Again, you'll notice that this is a quotient problem. I have the same bases, and they're being divided. That means I'm going to subtract my exponents. So I will have 2 to the negative 4th power. Remember that this is not a simplified answer. You cannot have negative exponents as a simplified answer. This is technically 2 to the negative 4th power over 1. And again, if I want to get rid of that negative, I have to move it to the opposite side. So I have 1 over 2 to the 4th power. And that can even still be simplified more because I know that 2 to the 4th power is 16. So this would be my totally simplified answer. All right, I'll do number 2 with you, and then I'll set you free. Here I can multiply 4 times 3 because those are just simple numbers. 4 times 3 is 12. And then again, when I have the same base with exponents being multiplied, I add those exponents. So that would be x to the 7th power. Again, I can't simplify this one anymore because I've got variables and I don't know what the value of my x is. So I would like you to work with your group to finish 3 through 10. And when you have them finished, press play so that you can make sure and check your answers and do a little bit more discussion with your group. All right, my answers are in the simplest form possible. So if you have an answer that's a little bit different, check to make sure that you actually went through and simplified all the way. Talk with your group, compare answers, make sure that everyone's understanding how we get from the original problem to the final, most simplified answer. When you feel like you got a good grasp on it, you can go ahead and press play to move on to the final talk the talk. All right, last thing for the day, talk the talk is basically just going over those 3 rules that were our goals for the day. We have the 0 power, which anything to the power of 0 is just 1. Obviously, we know that that does not work for 0 to the 0 power. We've also talked about negative exponents. If you have a negative exponent in the numerator or on the top, it needs to be moved down to the bottom so that it can become positive, and kind of vice versa for a negative exponent in the denominator or on the bottom. If you have a negative exponent on the bottom, it then needs to be moved up to the top so that that negative will go away. So kind of discuss with your group for a minute here, and then I will talk to you about the homework in just a second. So press pause and discuss for a little bit, and then we can all come back together at the end. All right, again, that Talk the Talk chart was really nice because it has all three of your new rules kind of worked into one table. So that page is going to be very helpful for you in the future as well. The last thing I wanted to talk to you before I let you go is just that your homework tonight is to do the 13.3 worksheet, and both homework assignments, the 13.1 and the 13.3, will be due on Thursday. So again, depending on how you guys want to work around the video lessons and the homework, it just all needs to be done on Thursday when I get back. So I will see you guys tomorrow.